architecture means it's kind of made more general. So we separate connectivity from management and control. For example, in the field, you might have different connectivity in the sense that you might have nodes from AT&T, from Sprint, from any type of connectivity in the field. And here might be the Purdue realm. So basically, even though nodes talk to each other at that connectivity level, the rules and the management is done here. So this enables a lot of flexibility. Today, we are under the tyranny of connectivity. Even security is done at the connectivity level. So we put rules at the routers, okay? And if you have to change anything, you have to go to each router and to change it. And depending on connectivity, you can do things or you cannot do things. Here, it's a lot of flexibility. It doesn't matter how the connectivity happens. At this level of management and control, you can apply your policies. Okay? And of course, these realms, which is management and control, somehow they fit very with organization. Let's say you have a university, has presidency, has different levels of offices, and the realm of networks will really mirror this situation. So you can put in place policies and rules at each of these levels, and they will apply to their below levels. So basically, boundaries between could be anything, could be technological, governmental, organizational, and so on. Now, let us focus more on security. What we talk so far has at least 3 strong features which are related to security. First of all, we have very well-defined context of networks. We separate management and control from data, and we allow the use of policy servers. So what does it mean, this well-defined bounded context? As I said, separating management from connectivity enable a given administration who has to handle the network to define policies at any type of level. For example, you can, like in real life, when you come to a country, you have to show the passport. That's the first level of security, right? At the country level. Then you go to building, you have another type of security. Inside the building, you can access some rooms and don't access others. So all these are rules defined by a given organization. The same thing could be done in network now. Depending on your architecture of the network and rules you want to apply, you can go rules for single nodes, group of nodes, level of nodes, and so on. So basically, as I said, this is just a mirror of real life. Separation of management, control, and data. Today, actually, one could send packets on the internet which could look like routing commands and disrupt the whole internet or major parts of it, because there is no separation between data and control. So the damage could be really big. So by separating them, we would like to make this not possible anymore. Policy servers. Now, in these realms, we can place servers, and these servers can help us to do all kind of authentication, which authentication is one of the weakest points in internet. And now, as I said, you can do authentication not only at the gates of your networks, you can do authentication at each level, at each node, whatever type of policy you might need to deploy. So basically, one output could be that you because of these policies could be designed in different levels, the security also could be like this. You have security at country level, at city level, at house, at room, whatever level you want. Basically, if you compare with the previous slide, initial slide, which I said we are facing very unscalable situation, here you don't wait for enemy here at your castle. You try to stop it whenever it's possible or whenever you want, okay? So, and this, it's made possible by these policy keepers, which are these servers in real areas, okay? So basically, organizations now are in full control of their security. So basically, we go from the default situation is you permit anything. We try to stop as soon as possible bad things, right? So authentication, as I said, will be based not anymore on IP addresses, which means nothing. So what does it mean, IP address for this computer? Suppose now I launch some attacks from here, and who knows, it was me. Okay, you have to dig who was using this computer. But if my ID is connected with this computer for this time being, then I'm responsible. Okay, so it will guarantee non-repudiation of whatever actions. Basically, if you pick up a packet today, you are not sure who is the owner. There is an IP address, a source IP address, but what does it mean? It's faked or not? What we are proposing, each packet will have an owner. So you could see that whatever happens, there is somebody who did it. Okay. So and other many features which are part of the architecture. Now, how to go about this architecture? Because one criticism people have is that, as I said at the beginning, we weren't expecting that internet to happen overnight. So these are features, and not necessarily will happen at the same time. Most likely, people will take features from this architecture or other architectures which are being proposed, and in smart ways implement over the existing internet. For example, I can show you one case we are doing ourselves from our architecture. We have taken this mobility problem, and we are proposing to implement over the existing internet without changing anything. So how it works? It proposes a new type of service provider called mobile service provider, which will be kind of based on kind of value-added service. So basically, if you need mobility, you have to pay for that mobility, this special service provider, and this special service provider will follow you, will make sure that whenever you go, packets arrive to you and not at your home address, and this could work even today internet. Now, why this is not happening today? Because our mobility is based on mobile IP, and for some reason, not only technical but mostly commercial, service providers don't have incentive to apply it. Okay, but in this type of, let's say, light architecture of mobility, this service provider will be paid to do that, and of course, only people who might need security mobility will pay and will get this service. And the same thing can be applied for security and so on. So basically, I won't go in details, but just to show you that even in existing internet, without changing many things, we could have much better mobility. Now, let me move on some other scenarios. And the one we are talking now is regarding sensor networks. Now, a lot of work has been done on sensor networks. We are tackling another aspect. Sensor networks are built of small nodes, usually, with limited battery, and the life of this battery is not very large. I mean, sooner or later they will lose their energy, and we have to replace sensors. So basically, in real life, when you have a sensor network, you will have many deployments, not only one. Now, what happens about security? As I said, a lot of schemes are proposed about security, but when you have several deployments, then you might be in trouble because your adversary during time might capture single sensors. And when they capture a given device, they can take out all keys and all security schemes you have applied for the deployment. And now, if you keep the same keys for all deployments, of course, you will be in big trouble because they know now the keys. So what we are offering a way to better handle these many deployments from the security point of view. So instead of having the same keys for all deployments, we are saying keep each deployment with their own pool of keys. So at least if some keys are captured for a given deployment, they won't be able to use those in the next deployment. The problem now becomes how these deployments talk to each other, because to have the same network, they have to talk. So for this reason, we introduce some bridge nodes. The idea is a simple idea. In this case, in this figure, we show the application